Hello, everyone. So today in math, we are going to go over percentages, and hopefully this will give you a general overview of what to look for when you're working on your homework and when you are studying for the quiz. So percents, fractions, decimals even, all of these represent part of a whole. A percentage is just a way of thinking about a portion of a whole number. For example, if we take 50%, 50% is the same as 1/2, and either 50% or 1/2 of 10 is 5. If you have $10 and I take 50% of your dollars, I've taken 5 of your dollars. There are some percents that you should definitely know their fraction equivalent. For example, 1/2 is the same as 50%. You should know that 1/4 is the same as 25%. 3/4 is the same as 75%. And of course, 1, just the number 1, is 100% or the whole of something. A percent, when we write it as a fraction, is always written over 100, unless it has a decimal. We cannot have something like that, 12.5% over 100. You can't have a decimal in a fraction. We will look in a minute at what you do if you have a decimal in your percent. But for now, if your percent is a whole number, you just write it over 100 to turn it into a fraction. So 45% would be 45 over 100, 2% would be 2 over 100. Of course, reduce these down as you can. This would reduce to 9 over 20. This would reduce to 1 over 50. That's how we go from a percent that's just a whole number to a fraction. So we can also write decimals as percents and percents as decimals. These interchange very easily together. We'll look first at going from a percent to a decimal. So to write any percent as a decimal, we just move the decimal spot 2 times to the left. That's it. So our example here, we have 33%. The decimal in our 33% is hanging out here at the back, at the very right of the number, where all decimals should be in a whole number. And that decimal is going to move 2 times over to the left in order to give us 0.33, not 0.33%, because 0.33% and 0.33 as a decimal are not the same thing. So this is not a percent. We've gone from percent to decimal. Let's look at another example. How about if we have 54%? Where is the decimal in our 54%? Well, it's right here, at the end of the percentage, right at the very right of the number. And to turn that percent to a decimal, that decimal is going to move 2 spots over to the left. We'll drop it there and have 0.54. Now this is true about any percent. Doesn't matter what kind of percent it is. If we have 0.03%, that decimal, to change our percent to a decimal, is still going to move over twice to the left, drop it there, and now we have 0.0003. That's it. Nothing fancy, no strange different techniques, nothing excessive. Now, to go the other way from a decimal and change it to a percent, we move our decimal 2 times over to the right. So you're only going to move your decimal twice, and you're going to move it right or left depending on where you're going. Think about all the times you've danced the Cupid Shuffle at somebody's wedding. This is all coming back to you now. So here's our example here, our decimal of 0.76. Here's our decimal. That decimal is going to go 2 spots over to the right to give us 76%. Decimal hangs out at the very back of our whole number, as it does in any whole number. And again, this is true no matter what decimal you're dealing with. If we have 1.5 and we wanted to turn 1.5 into a percent, that decimal will move 2 spots over to the left, or to the right, sorry, We'll drop a 0 there where our extra space is, and we'll get 150%. Or let's say we have 0.3, and we want to turn that into a percent. We'd go over once, twice at a 0 because there's nothing there, and get 30%. Or if we had 0.002, that would be, our decimal would go over once, twice to the right, and give us 0.2%. Quite often I see my students try to think way too hard about this technique. Well, if it has a decimal in it, I should move it 3 times, or if it's a full moon, then I should always go to the right. Don't think really hard about this. You're only going to go twice, and right if you're going from percent to decimal, left if you're going from decimal to percent. So let's get back to that percent with a decimal. We have 12.5%. How do we write that as a fraction? We can't write it as 12.5 over 100 because we can't have decimals in fractions. So instead of that, we have a 2-step process here. We're going to convert our percent into a decimal, that's step 1, and then turn our decimal into a fraction. Hopefully you guys remember that from the decimals lecture several weeks ago. So first step, convert our percent to a decimal. Here's 12.5. How do we go from a percent to a decimal? Well, we move the decimal 2 spots over to the left, and that gives us 0.125. Okay, next step, how do we go from a decimal to a fraction? Well, remember that everything to the right of your decimal will become your numerator. That's where we get our 125. And then our place value of our very last number in our decimal, the 5 in this case, determines our denominator. So the 5 is in the hundredths place. You may want to go back and review your place values. The 5 is in the hundredths place, so our denominator will be, or thousandths place, sorry, I might need to go back and review my place values. 5 is in the thousandths place, so our denominator will be 1,000. So 12.5 is not 12.5 over 100. 12.5% is 125 over 1,000. And when you reduce that, this reduces down to 1/8. So make sure that you're paying close attention to your percents with a decimal in them. Now, if this was all that we were doing with percentages, we were just turning them into decimals and turning them into fractions, that would be really nice and really simple and really easy. But the reason why we talk about percentages is because they're incredibly useful when we're trying to figure out actual stuff going on in the real world. And I have a bunch of examples right here for you of how we would use percentages practically speaking. So here is our first one. This is data as of May 26. So for Colorado, this is from the CDPHE, the Department of Public Health and Environment. Colorado has tested approximately 154,000 people for COVID-19, and they've found approximately 24,000 cases. So what percentage of the people who have been tested for COVID-19 actually tested positive for COVID-19? This is the kind of place where you would use decimals, either to determine a part of a whole or to find part of a whole. So essentially what we're asking here is 24,000 is what percentage of 154,000? And the easy way to think about this, again, because percents can be written over 100 as a fraction, is this formula right here. Percent over 100 equals is over of. Okay, well, percent over 100 makes sense, but what on earth is and of? Is and of refer to which numbers are right next to is and of. So in this case, we have 24,000 is what percent of 154,000. That's what we mean by is and of. So when we substitute these numbers in for our formula, we get percent over 100, because this is what we're looking to find. We want to know what percent of people tested positive for COVID-19, equals 24,000, there's our is, over of 154,000. And this technique we talked about with ratios and proportions. Remember, this is cross multiplying. This is a technique that will serve you very, very well for the rest of your medical career and even in situations beyond that. So make sure that you are taking good notes on cross multiplication. Make sure that you feel very comfortable with the technique. If you don't feel comfortable with it, or if you have questions, please come see me during office hours and we can talk about it, because this is something that will put you yards and miles ahead of other folks who are not comfortable with this, especially when it comes to things like drug conversion and dosage conversion. Okay, so here is our setup. So let's go over then good cross multiplication technique. So first step is to multiply your corners and set them equal to each other. Hopefully you remember that. So we'll do 100 times 24,000 is equal to 154,000, times our percent, our mystery number. Second step, then finish that multiplication. So we'll do here 100 times 24,000 equals 2,400,000. And we just copied down the second half of the problem. So far, so good. Now, to finish our problem, we need to divide. We divide by the number that's multiplied to your variable. Do you guys remember what a variable is? The variable is your mystery number. This is what you're trying to solve for. In this case here, that's our variable. The missing percent that we're trying to find. So that means we'll have 2,400,000 divided by 154,000. I promise your problems on your homework will not have such big numbers. And when we do our division, and you can plug this into a calculator because these are real big numbers, our answer is, go ahead and plug that in your calculator really quick, you should get 15.58%. Or we could round it up to approximately 16%, though the CDPHE is probably staying more specific. So far, out of all the people that the Department of Public Health has had tested for COVID-19, 15.58% of them have come back positive. Let's look at another example. So here we have what percent of 50 is 5. So if you remember using our formula, percent over 100 equals is over of. Let's go ahead and fill in our formula. So percent over 100, we don't have a percent. Our percent is what? That's what we're trying to find. And then how about is over of? Well, is, we have is 5 and of 50. The smaller number generally will always be on the top, the bigger one on the bottom. So now from here, we can cross multiply. So our percent, our missing number, times 50 equals 5 times 100. Percent times 50 equals 5 times 100, which is 500. And then what's our next step? We'll divide. We'll divide by the number multiplied to the variable. So 500 divided by 50. So 50 goes into 50 once. 1 times 50 is 50. Subtract and get 0. Bring down the next 0. 50 goes into 0 0 times. So our final answer is 10. So 5 is 10% of 50. How about this? 11 is 25% of what number? So again, using our percent over 100 equals is over of. Here's our percent right here, 25. So we know we have 25% over 100. And then is over of. Well, we have our is. We have 11 is. But what about our of? That we don't have. So that's our missing number. That's our variable. Okay, cross multiply. We get 25 times mystery number equals 100 times 11. And then when we multiply, we should get still our 25 times our mystery number. 100 times 11 is 1,100. And then we will divide. Divide by 25. So how many times will 25 go into 1,100? Well, 25 will go into 110 4 times to get 100. Subtract, get 10, bring down your 0. And then 25 will go into 100 4 times again to get 100 and subtract and get 0. So 11 is 25% of 44. Great, let's look at this one. What percent of 16 is 9? So here we're looking to find our percent. Right, our percent is what? We don't know. So that'll be percent over 100. And then is over of. We have of 16 and is 9. So let's go ahead and cross multiply. 9 times 100 and then percent times 16. Okay, 9 times 100 is 900 equals our percent times 16. And then next step, we're going to divide. Divide by our 16. 900 divided by 16. Okay. So 900 divided by 16. Well, let's start with 90 divided by 16, which will give us 5. 5 times 16 is 80. Subtract and get 10. And then bring down the 0. And 16 goes into 106 times. 6 times 16 is 96. Subtract and get 4. Now what? Do we call it a remainder? Can we have a remainder in a percent? What should we do next? Well, next thing we should do is add a decimal and a 0 and bring that 0 down. Bring that decimal straight up into our answer and keep going. So now we have 40 divided by 16. 16 will go into 40 twice. 2 times 16 is 32. Subtract and we'll get 8. Add another 0. Remember, that's the glory of dividing with decimals. You can just keep adding zeros until you finish your problem. So now we have 80. Well, we know already that 16 times 5 is 80. Subtracting it 0. No more numbers to bring down. No more leftovers here in our subtraction. So we are done. Our percent is 56 and 25 hundredths, or 56.25%. Let's look very quickly at something that you are going to see in your homework that you should be very comfortable with, and that's going back and forth between equivalent forms. How do you write a fraction in its equivalent form as a decimal and as a ratio and as a percent? We'll take a look at a couple examples of this, starting with our fraction up here, 3 over 10. How do we write 3/10 as a decimal, as a ratio, and as a percent? Well, let's start with ratio because this is going to be the easiest because our fraction essentially is our ratio. We could write 3 to 10. We could write 3 over 10. We could write 3 to 10. Any of those would be acceptable, but there's no difference there really between our fraction and our ratio. Now, when you're doing this in your homework, make sure that your fraction and your ratio are reduced to their lowest form. All right, so we have a ratio, decimal and percent. Which one should we do first? Let's start with the decimal because we need the decimal in order to make the percent. So do we remember, how do we turn a fraction into a decimal? This is a technique that you should have committed to memory by now. So to turn a fraction into a decimal, you divide the denominator on the outside, the numerator on the inside. And then start by putting down a decimal and a 0. Bring your decimal up into your answer. And then how many times does 10 go into 30? Well, 10 goes into 33 times. 3 times 10 is 30. Subtracting, get 0, and we're done. So our decimal is 0.3, or 3/10. We have our decimal. How do we go from a decimal to a percent? That's the last thing we need for 3/10. Well, we take our decimal, and to go to a percent, we move over 2 times to the right. So 0.3 as a decimal converts to 30%. So far, so good. Let's take a look at 85%. That we're kind of starting the very end of our spectrum. So where would be the best place to start here? Well, let's turn our percent into a decimal first. 85%. Remember that for any whole number, the decimal is always just kind of hanging out here at the very back of the number. So he's back there behind that 5. And remember, to go from a decimal to a percent, we went to the right. So to go from a percent to a decimal, we're going to go the other way, to the left, over twice, to get 0.85. So there's our decimal. Now, we need a ratio and we need a fraction. Well, how do we write a percent as a fraction? This guy is just a whole number. There's no decimal in that percent. So remember, we can write a percent over 100 to make it into a fraction, as long as it doesn't have a decimal in it. So 85 over 100, let's reduce that. Make sure that it's the smallest form possible. We can divide by 5. Anything that ends in 5 or 0 can be divided by 5. So 85 divided by 5 is 17. 100 divided by 5 is 20. And 20 is 20, the only multiples of 20 are 4 and 5 and 2 and 10. 17 is a prime number, so we're done. We cannot reduce 17/20ths any further. Okay, we have our fraction. How about a ratio? Well, that could be any number of answers. 17 to 20, 17 over 20, 17 to 20. Either of those would work. You can put any of those down for the answer on the homework. Please only put one of those down for the answer on the homework. And there we go. We have our 4 equivalent forms here. Our numbers expressed as a fraction, as a decimal, a ratio, or a proportion. Let's look at another example relating to the Department of Public Health and our current health crisis. There are 64 counties in the state of Colorado, and currently 60 of those counties have reported a COVID-19 case, at least one. So what percentage of the counties in Colorado have reported COVID-19 cases? So what we're asking here is 60 is what percent of 64? So again, remember our formula, percent over 100 equals is over of. And don't worry about trying to figure out how to go from here to here in your homework. You'll be given a setup that's very similar to your percent over 100 equals is over of. I'm just using examples because they're pertinent right now. So 60 is what percent of 64? Here's our is, 60 is, and our of 64. So we're going to get percent over 100 equals 60 over 64. And then cross multiply and go to town. So multiply your corners, set them equal to each other. That gives us percent times 64 equals 100 times 60. Complete your multiplication. 100 times 60 is 6,000. And then divide by the number that's multiplied to the variable. Divide by the 64. Just remember the percentage, that is your variable. So 6,000 divided by 64 is 93.75. So approximately 94% of the counties in the state of Colorado have reported at least one COVID-19 case as of today, May 26, according to the Department of Public Health and Environment. More examples. You have a stock of 750 N95 masks in your clinic, and you've used 35% of them in the last week. So how many masks do you have left? The doctor asks you, how many masks do we have left? Sends you in the back room with some paper and a pencil. Now you have to figure out for him so you can order more masks. So we're looking to find here, what is 35% of 750? So now we know what our percent is. We're looking to find our missing number here. What is, and then of 750. So we'll have 35% over 100 equals, we don't know what our is number is. That's why he's a little question mark. Here's our variable. Over 750, which is our of number. And again, just like previously, we are going to cross multiply and solve to see how many masks we have left. So we'll do 35 times 750, set that equal to 100 times our variable. 35 times 750, so there's step 1, step 2. 35 times 750 is 26,250. Now we're going to divide by the number multiplied to our variable. So we get 26,250 divided by 100 equals 262.5 masks that you've used. We'll round that up to 263. But wait, you've used 35% of your masks. We want to know how many masks do you have left. So is 263 our final answer? Nope. Because we started with 750, we used 263, we have 487 masks left. Last example here. Now you are a shady pharmacist working in New York City, and you're trying to peddle hydroxychloroquine as a cure for COVID-19. Rest in peace, all of your lupus patients. You have purchased bottles of the drug for $15 each, and you're marking them up by 95% to sell to your unsuspecting customers. How much are you selling your bottles of hydroxychloroquine for? This is another two-step problem that we're looking to find. So what do I mean by marking up your bottles of hydroxychloroquine? If in any pharmacy, shady or otherwise, whenever you purchase medication, you're going to sell them for a price that's higher than the price you purchased them for. If I'm selling doxycycline and I buy a bottle of 100 doxycycline for $5, it's a pretty cheap antibiotic, I might sell that bottle of doxycycline for $10. And then I made an extra $5 on that doxycycline that I can use to buy more expensive medication or pay my pharmacy tax or pay the electricity bill, whatever it may be. So that's what I mean by marking up your bottles of hydroxychloroquine. You're not going to sell them for $15, otherwise you won't turn a profit. So let's start with, what is 95% of $15? How much more am I going to mark up these bottles of hydroxychloroquine? So what is 95% of $15? 95 is our percent. What is our variable? And is, is 15. So cross multiply, 95 times 15 equals 100 times x, or 100 times our little question mark. 95 times 15 is 1425 times 100, or equals 100 times our variable, and then divide each side by 100. Divide by whatever's multiplied to your variable. So we have 1,425 divided by 100, which equals $14.25. So that's my markup. I'm going to increase the price of the hydroxychloroquine bottle by $14.25. So now I need to figure out what am I actually going to sell my hydroxychloroquine for. So I bought them for $15. I'm increasing the price by $14.25. So my final price when I'm selling my hydroxychloroquine is going to be $29.25. I had the markup there, and that's what I'm selling my bottles of medication for. So hopefully this was kind of a brief overview of what we do with percentages, how we use them, and a good review on cross multiplication. Again, make sure that you're very comfortable with cross multiplication because you will be using that forever. You'll use it a lot when you get to your pharmaceuticals and your back office type stuff. As always, if you have questions or would like to further go over this topic or want me to check a homework problem for you, please drop by office hours. I would love to see you there.